Assalamualaikum and very good morning. My name is Norfirdaus Rustu. Today I will explain about my undergraduate project 1, section 21 and 22. That is, the title is the effect of changing air supply flow rate of the flameless combustion to hot air generator performance F-HAG. My name is Norfirdaus Rustu. The metric number is CNY190101. The supervisor is Dr. Adam bin Kasani. Firstly is the introduction. The first research background. Firstly is the hot air generator is used to heat any type of space that requires efficient heating. Besides, in many industries, hot air generator is always used for quenching and drying product to make a final product. Second is hot air generator operate using conventional combustion. Third is the conventional combustion produce high level emission such as NOx and CO. NOx is nitrogen oxide and CO is the carbon monoxide. Fourth is the flameless combustion is a method used to reduce NOx and CO emission. And lastly, UTHM aims to promote flameless combustion into hot air generator to a semi-industrial industry. Okay, second is the problem statement. Firstly, in most industry, they were using conventional combustion for hot air generator. Second, in using a conventional combustion, it has produce a vast amount of pollution. That is, the pollution affects humans by damaging the ecosystem that they rely on in water and on land. Such as in water, people use water for our life, that is bath and drinking, and land, we use oxygen in the air to breathe. Second is the third is the conventional combustion generate high emission of pollution NOx and CO. And lastly, there is no experimental study about the effect of changing air supply flow rate towards the rate of emission produced by flameless mode. This is the objective of the project study. Firstly, to determine the effect of a supply flow rate of the flameless combustor to hot air generator performance in terms of maximum temperature and temperature profiles. Second, we want to do experimentally determine the rate emission of NOx and CO when the air supply for the flameless combustion mode is changed. For the scope of study, firstly, the use of the liquid petroleum gas LPG for the fuel supply. Second, in this project, we use a single fuel inlet that installed at the inlet flank of the combustion on the combustor. Third is 4 air injector is used to supply the combustion air through the front of the combustor, and the range of air supply towards the combustion is 4.8 until 39 multiplied by 10 the power root of -4 kg per second only. Okay, the significance of this project study is firstly to apply this knowledge can be applied to other type of difficult type to burn fuels such as heavy oil and biofuel. Second is this project study can provide a high stagnation temperature with small losses in stagnation pressure and low pollution emission towards the use of hot air generator. Third, this flameless release extremely low level of NOx and CO to almost zero to the atmosphere. This can make this project is a green technology. And lastly, is increase the equipment lifetime. Okay, this is a literature review. For the first point is the flameless combustor. Okay. Firstly, the peak temperature of flameless combustion should be less than 1300 degrees Celsius. 1300 degrees Celsius is the thermal NOx for formation temperature. This is because the nitrogen oxide form at the temperature above the 1300 degrees Celsius. Second, inside the temperature of the combustion chamber should increase over the auto ignition of fuel. Third, the longer component time are all related to the ability to produce a homogeneous mixture. This will help to get the flameless mode on the project. Fourth is flameless combustor require a high rate of exhaust gas recirculation. This exhaust gas recirculation will help prevent overheating to the combustor. And lastly, an invincibility of the flame front inside the combustion chamber. For the second point of literature view is difference between flameless combustion and conventional combustion. Okay, in the diagram in the figure below, in the left is a conventional combustion, that is we can see the flame front of the combustor, and on the right is the flameless, that is we cannot see the flame on the inside of the combustion chamber. Okay, there is a difference between the conventional and flameless. Firstly, in conventional, there are a thin layer of the combustion zone that is occur at the flame, that is a mixture between the air and the fuel. Seconds, in the conventional combustor, it produces high level emission of CO and NOx. And lastly, it is a low in efficiency because we need to readjust the temperature if it's rise above what we want. Okay, for the flameless combustion, the combustion zone throughout the whole combustor. Second, it can reduce emissions of CO and NOx. And lastly, it's very efficient for the hot air generator to produce temperature for the drying. The third point is the combustion pollution. That is three studies of the pollution, that is CO, carbon monoxide, UHC, unburned hydrocarbon, and lastly NOx, nitrogen oxides. Okay, for the CO, that is main way to reduce CO is emission is to control equivalent. Second, CO concentration increase steadily as the equivalent ratio increase. Third, the CO concentration can drop rapidly with the temperature. Okay, for the NOx is the combustion below 1300 degrees Celsius form a lower concentration of NOx. Second, the NOx pollution is formed at high temperature in a flame. Okay, for the UHC, that is unburned hydrocarbon. Firstly, the emission of the unburned hydrocarbon from the cylinder in the spark ignition engine. And the second is increasing the work area or quenching area of the combustor will increase the UHC. For the methodology, this is the flowchart of my planned project. Firstly, start, and next we go through to the problem statement of the identified project. What is we want to solve for this project. Third is the literature review. We find any article related to the flameless combustor. And fourth, we design and develop the flameless combustor for the hot air generator. In this phase, we design the combustor using in a SolidWorks software. Okay, then we continue to the prototype fabrication. we fabricate the flameless combustor at the shop, and after that we continue to the prototype testing. If the prototype is not functioning well, we need to redesign and develop the flameless combustor again until we can get the best result. If the prototype testing is can functioning well, we can continue to the experimental setup at the location. Next, we can continue run the experiment data and collect the data for the experiment. After that, we run a data analysis to get the information and what we want to test in the project. That is the level of NOx and the temperature inside the combustion chamber, to the performance of the hot air generator, and lastly conclusion and the end. Okay, lastly there is a expected outcome from this project. Firstly, we will hope that the temperature of hot air generator will be more stable uh, when we use flameless combustor than the conventional combustor. Second, there is no visible flame in the combustion chamber. This is because a flameless mode need conditions to there is no visible flame like a conventional combustor. Third, the temperature distribution spread evenly throughout the combustion chamber. This will help to get the temperature inside the chamber is stable and same at any angle of the combustion chamber. And lastly, NOx and CO emission are very low for the fuel gas combustion. This can help to reduce pollution emission to the atmosphere for semi-industrial industry. Okay, that's all from me. Thank you.